So another one is, again, this next part, just flip your paper, is difference of sum of two cubes. And so this is our 3A, our 3B.3 part 2, okay? It's method number 7. It's difference of sum of two cubes. So remember how we talked about perfect squares, right? Well, there are perfect cubes. Perfect cubes are numbers that are products of a number times itself 3 times. Does that make sense? So, for example, our smallest perfect cube is 1 cube, and 1 cubed equals 1. After 1, we have 2 cubed. 2 cubed is 8. After 2 cubed, we have 3 cubed. 3 cubed is 27. Does that make sense? Then we have 4 cubed. 4 cubed is 64. We have 5 cubed. 5 cubed is 125. And you keep going and going and going. Make sense? So a cube is just 2 times 2 times 2. 3 times 3 times 3. 4 times 4 times 4. 5 times 5 times 5. Bam, right? Those are our cubes. So what is their rule? There is a sum or difference, whereas with perfect squares, there's only a difference of 2 squares, right? With cubes, there are there are 2 of them. You have a sum and you have a difference. So when you're doing it, you have to identify what's your A and what's your B. Your A equals the cube root of your first term. That's an ugly 3, but your first term. Your B equals the cube root of your second term. And then you just plug the values into the pattern. Okay, so for a completed one, we're going to look here. We have 8x cubed plus 1. Well, the cube root of 8x cubed, cube root of 8 is 2. Cube root of x cubed is x. So this is now my 8. The cube root of 1 is 1. And you're just going to plug them into the formula where they go. So we end up having, this was a squared. This is a times b, and this is b squared. You just literally plug them in where they go. The hardest part is going to be finding them. The easy part is plug them in. Okay. All right. So we're going to do an example. You just follow the pattern. You find your A, you find your B, you plug in. You find your A, you find your B, you plug in. Got it? Let's start. So we have x cubed plus 27. X cubed plus 27 means that I'm using this rule, right? Because it's adding. So the first thing I got to do is find my A. Your A equals the cube root of your first term. My first term is x cubed. What is the cube root of x cubed? X. Then your B equals the cube root of your second term. Your second term is 27. What is the cube root of 27? 3. So everywhere there's an A, it's not a highlighter. Everywhere there's an A, we're going to plug in X. So everywhere there's an A, it's going to become an X. Everywhere that there's a B, it's going to become a 3. Everywhere there's a B, it becomes a 3. And that's where we're plugging them in. Okay, so we end up with, where'd my pen go? Y'all see the dot? See it now. So we end up with x plus 3 times x squared minus x times 3 plus 3 squared. Sorry, recording. I have my window open, so if you hear extra stuff, it's outside the window. Okay, so we have x plus 3. Now we're going to clean this up. What's x times 3? 3x. What is 3 squared? 9. So our answer is x plus 3 times x squared minus 3x plus 9. So first you find your A, find your B, plug in. Find your A, find your B, plug in. Yeah? All right. Let's try another one. So notice this time, instead of it just being a variable, we have a number and a variable. We have a coefficient. So our A equals the cube root of the entire first term. 8x cubed. What is 8x cubed? Cube root of it. What's the cube root of 8? 2. What's the cube root of x squared? X cubed. X. Now we're going to do our b. Your b equals the cube root of your second term, which is 125. What's the cube root of 125? 5. Now I have my a and my b, and which rule am I plugging it into? The first one. So a plus b times a squared minus a times b plus b squared. So notice, if you're good at mental math, can you simplify as you're doing it? Yes, you definitely can. But for the sake of notes, as your teacher, I'm going to write it all out. So we have 2x plus 5 times, what is 2x squared? That means 4x squared. Minus 2x times 5, which is minus 10x. And 5 squared is 25. How we feel? Guess whose turn it is? Oh my gosh, you're so smart. Okay. But before I let you fly, little birdies, what do you notice this one has? It has a GCF. So before you can follow a rule, you need to find the GCF. What is the GCF here? 3x. So I'm going to take out 3x first. So I'm left with 3x, x to the third minus 1. And now go quickly. Find your A, find your B, write the factors. What is the cube root? The cube root A and B are cube roots. A and B are cube roots.
I'm not. Yeah. Where's my phone? I didn't do it. Bye.
All right. So in this case, what is your A? What's your A? A is X. And what was your B? B is 1. So you're going to just plug those into where they go. This time you're using the difference. So you have x minus 1 times x squared plus x plus 1. And do not forget your GCF. If you forget the GCF, then it's not the same problem. Do not forget GCF. If you made a mistake, do you see it? Questions, comments, concerns? Yeah. All right. So in conclusion, if the A term and C term are perfect cubes, then you factor them by taking the cube root of each term, right? And follow the pattern to create the binomial and trinomial factors, okay? This is where we're going to stop at, and then you're going to pick up here tomorrow, okay? So this is what you're going to come in tomorrow. You're going to work on, and then we'll go over example 4 with 8x to the 4th plus 27x, and then we're going to go over example 5 with 64x cubed y plus 125y to the 4th, okay? All right. If you can do those two, you can do anything.